Okay, so let's go back and take a deeper look at the complex class that we wrote other to represent complex numbers. And we're going to use this as an avenue to discuss the copy constructor and assignment in among objects in C++. Okay, so first I want to point out an idea that there are these several functions that objects have that we call special member functions. One of them is a default constructor, like we just talked about. We've also talked about the destructor last week, right? It gets run whenever the object is deleted. And then there are several more that we haven't yet really seen or talked about. The copy constructor, the assignment operator, and the move constructor and operator. The last one we're going to ignore for now. But in this video, we're going to look at the copy constructor and the assignment operator a little more deeply. And why do we call them special? Well, we call them special because every object has to have them or say something about them. And if an object doesn't have them, then the compiler implements them automatically. And they're always there. They're always happening, possibly implicitly behind the scenes, helping an object do its job and work the way a programmer expects an object to work. And so understanding what objects are at a deeper level means we need to understand these special member functions. So here's how we left the complex class that we had written before. We had a couple of private members to represent the real and imaginary part. We had a constructor that would take the real and imaginary part as an argument and then initialize the two fields for us. We have a function that will do adding of two complex numbers. We can implement others. I'm just trying to keep the object small to make it fit on one page or one slide. And then also have added a print function here that'll just use cout to print the real and imaginary parts so that we can look at it if we want to. So if we were to run this main function along with this object and print it out x, then we would print something like 1 plus 0j. All right, now what if I changed this code and wrote complex x equals j? Would that work? Well, it turns out it would. What we're doing when we write code like that is we're asking x to get initialized from a different object, from object j. And in C++ jargon, this is called a copy because I'm making a new object from an existing object, right? And then there'll be two objects. There'll still be j, but now there'll also be x as well. And I don't have to change this complex object in any way to make this work. And the reason is that this gets supported by one of those special member functions that the compiler makes for me behind the scene. It's called a copy constructor. And it is a constructor, just like the other constructors we've been talking about. And that copy constructor will do the job of initializing my new object x from j. Right, so there are three common cases in where this copy constructor is needed and where it gets used a lot. And one of those cases is in a variable declaration with initialization that I just showed you, right? If I say complex x equals j, that I'm declaring a new object and I'm initializing it from j. So that's going to be a copy. That's going to use a copy constructor. And then when I'm passing an object to a function, then in order to pass it into that function, right, an existing object is going to get is basically going to get copied into the argument of the function that's being called. It's a pass by value, so we copy the object in. That's another use of the copy constructor where the contents of the object get copied. And then returning an object from a function also results in a copy because we need to take an object that's possibly on the stack of a function that's going to return and copy it into the activation record of the function that's still there. And that requires some mechanism to do the copy back. Okay, so these three things that actually occur quite a lot in any sort of C or C++ program all need a copy constructor. And for our simple complex object, the compiler is nice enough to make it for us automatically. Another case that you may be wondering about is assignment. What if I declared another complex variable C, and I were then in a later statement to say C equals Y? Now, this may, at first blush, this may look like the previous code to you, but it's very different. It's not the same as X equals J. When I say X equals J, I'm initializing X with J. And that means that at the time I make X, I'm initializing it. This is a copy. But down here, I've already made C, and then I'm initializing it with Y. And actually, if you're paying close attention, you may notice a bug here. I don't have a default constructor in my complex class, but I declared C to use a default constructor. So have a little problem there. We need to come over here and add some default values, or just add another constructor that'll initialize everything to 0. Assume that we have that. I'm not trying to trick you here in that regard. So assume we have a default constructor, then we will default construct C and initialize it to 0s, let's say. And then I say C equals Y. What this means is I want to assign the content of Y into the variable C. So I need to copy all the information that's in the object Y into the object C. And that's an assignment. And it is much like a copy, the only difference being that object C already exists, whereas in the previous case, X was just then being declared and didn't exist yet. Okay, this is an assignment. And really, you know, whenever we talk about assigning objects to each other, this is always done with the assignment operator. Okay, so there's always going to be some code that looks like, you know, C equals Y, right? The object we're assigning to equals the expression or object we're getting it from. And, you know, I can't say it enough. Assignment does not occur in a declaration. That's a copy. Okay, so just by default, when I implement an object, especially this complex object, then the compiler provides for me support to do copying and assignment. You know, why does this work, or how does the compiler do that? Well, by default, copy and assignment of classes is basically the same as copying and assignment of structs in the C language. And if you think back to 209, you may be able to conjure up the, you know, how that works. But basically what it is you just copy the fields one at a time over to the other object, right? So I have a real field and an imaginary field in the complex number. And so what I'm going to do is, from the object I already have, I'm going to copy the fields one at a time into their same locations in the new object. And that's really all I need to have happen. And it's pretty easy to see why a compiler could do that automatically for us, because it knows how many fields are in each object, and it can just do the copying. You know, it kind of looks like this. So if I say X equals J, then the compiler needs to generate some code that's kind of like X.real equals J.real, and X.imag equals J.imag. And then the contents of J have been successfully copied over to the context of X. But, you know, conceptually, this is what's happening, but that's not actually what we would want the compiler to do, because it would violate encapsulation, right? We don't want it pulling our private members out into the code and doing the copy here where we're using X and J. That would be bad. So what really happens under the hood, where you can't normally see it, you know, unless you know how to go in and look at the assembly code that the compiler is making. In reality, what the compiler is doing is it's adding a copy constructor into the class. And the copy constructor looks like this. It has a very specific form. In fact, we can write our own copy constructors if we want to. And what the copy constructor, you know, does is it says, well, look, I expect to take as an argument another object of the same type, right? I'm in type complex, I'm in class complex, and I'm going to take another object of type complex, and just to make it clear, we'll call that other. And now I'll set real equal to others real, and I'll set imag equal to others imag, and that initializes my object using other, right? And that's exactly what we would think should happen, right? If I'm copying one struct to another, I copy the fields one at a time. So I could write out this code myself and place it in the object. Now there's some other stuff going on in this constructor that may look a little weird to you at first, like I've got a const here and I've got an ampersand here. Okay, so remember, ampersand in a function parameter or in a variable declaration means it's a reference. And so the reason we put a reference here is because we don't want to need a copy to call a copy constructor. If you think back, I said anytime we call a function and pass an object, we need to make a copy to do that. Well, we don't want to need a copy for a copy constructor. That would be a kind of infinite recursion that we would never get out of. And so when we call a copy constructor, we need it to be a reference. And that means what we're really doing is passing a pointer into this function, but the C language lets us avoid using that pointer syntax. And all we have to do is say, well, this is really a reference to another object I have somewhere else, and I'm going to use it to initialize my new object. And the purpose of const is to say that in the process of making a copy, I should not modify other. This variable being passed in, we promise not to change it. That's all that const means. This member function won't change other. And because we promise that in the parameter, we put this const label, the compiler will actually do that check for us and make sure that we never set other.real equal to -50, for example, or to some other value. It's gonna guarantee we preserve the contents of this other object. Okay, so anytime we want a copy constructor, we just have to follow this form. We make a constructor, right? That means it has the same name as the class. And then we specify a reference to another object of the same type that we're going to use to make the copy. And then we just spell out exactly how we copy the fields over. Now, because we can write out this code ourselves, we don't have to do this dumb field by field copy. We could actually change this and put the imaginary in the real and the real in the imaginary, but that would be crazy. Nobody would do that. But there may be other scenarios where doing something creative is actually called for in a copy constructor beyond just copying the fields over one at a time. And in fact, we'll see an example of that when we look at the stream object. Okay, so I think I forgot I had this slide. What makes it a copy constructor? Well, it has the same name. It has the same name as the class. The type it takes as an argument is the same type of object that we're making. So it's also a complex. We make it a reference to ensure it's efficient. And const is optional, but it's a promise that we won't modify the object we're copying from. Okay, so we can add this copy constructor instead of leaving it to the compiler. The thing is, if we do that, the compiler definitely won't make one for us. If we write our own, the compiler will assume we knew what we were doing and that we did it properly. So that could be a downside in some situations. But we can just add this copy constructor into our complex object and we get the same thing. There are some times when we have to implement a copy constructor, and there are times when it's better not to. Actually, for this class, for complex, there's no reason for us to implement it. I just wanted to pick a really simple copy operation to show you first. And so this complex number is so simple, right? We're just copying the real field from one object to the other object. But actually, the compiler could make this for us, so there's really no reason for us to write one. Okay, and then the assignment operator is similar. The compiler will make an assignment operator for us that if an object doesn't have one. And an assignment operator, would look like this for the complex number. And there are some things I'm getting into here that we haven't talked a lot about yet, so just bear with me and I'll clear them up in some later videos. But there's this neat thing we can do on C++ objects is we can actually specify custom operators. And an operator that every object has to have is assignment. And so the name of this function is actually operator equal to mean that this is the assignment operator that you can use when you assign one object to another. And so the object being passed in as the argument is the object on the right side of the assignment. And the object that we're assigning to is the object that we're modifying here. And so we're saying that the real part of the object we're modifying becomes the real part of other, and the imaginary part becomes the imaginary part of other, equal to the imaginary part of other. And then this last return statement is just returning a reference to the current object. And I'll explain a little bit more later about what that statement means. But what you should notice, and the most important thing to notice, is that these two lines are identical from the copy constructor. And so here in my assignment operator, I'm just doing the same thing I would do in a copy, really. And I'm telling the compiler through the name of this function that it's my assignment operator. And if I'm assigning one complex object to another, these are the statements I wanted to execute. And so I'm just like before, I could add this into my class, and then this function that I manually wrote will get invoked anytime I do an assignment. And if you wanted to check that, you could stick a printf in here, assign one complex number to another, and then watch that printf execute in the process of that assignment. Again, if I write my own assignment operator and stick it in a class, the compiler will not generate one for me. It basically overrides anything the compiler would do. And so I'm taking responsibility for the assignment from one complex number to the other. But just like for copy constructor, because this assignment's so simple, I'm just copying the fields one at a time, I really should just let the compiler do it for me. And I'm just doing this one here manually to show you what it looks like in a really simple case of this complex number. Okay, so in summary, classes support copying an assignment without adding any extra code. And this makes objects really natural, intuitive, right? I can make my complex number with this imaginary and real field, and then assign them to one another and initialize them from one another, and all works. And I pat myself on the back for how rapidly I can get some code up and working. Okay, now, because the compiler is helping me out by generating those functions, that copy constructor and that assignment operator. We can write them ourselves. So I showed you the basic template for a copy constructor, and I showed you a basic template for an assignment operator. And we can write those functions for ourselves if we want to take over responsibility from the compiler. In reality, there are times when we need to take it over, and there are times when we don't need to. For the complex class, we don't need to because it's so simple. But for other classes, we are going to need to. And that's going to be an example I show you in an upcoming video. Okay, and I would just say, if the default behavior works, if just copying the fields straight over works, then we don't need to implement them. But that doesn't mean they're not there. They are there. The compiler is making them for us, and they're doing this job of performing copies and performing assignments in our code, right? So like I've talked about implicit construction calls happening, even though we don't write them out. Now there are these implicit copy constructors running and implicit assignment operators running to do a bunch of work for us to make our objects easier to use.